ಎಲ್ಲರಿಗೂ ನಮಸ್ಕಾರ. I am Dr. Shivkumar, Assistant Professor of Physics. In the next few lectures, I'll be talking about an important chapter in mechanics known as rigid body dynamics. This particular chapter is prescribed for Mysore University students of first semester. So in this particular video, I'll be talking about the basic concepts such as the moment of inertia, radius of gyration, and then the theorems on moment of inertia. They are parallel and perpendicular axis theorem. The important learning objectives of this session are to understand the concepts of moment of inertia, radius of gyration, and then the theorems on moment of inertia. So to start with, let us try to understand what is a rigid body. A body which doesn't undergo any change in shape or size when external forces are applied. That means the volume of the body remain constant when external forces are acting on it. So if we consider any two particles, the distance of separation between those two particles remain constant or remains unchanged. So this rigid body can undergo translational motion as well as rotational motion. A body, when it moves as a whole in a particular direction, we call that motion as translational motion. For example, a moving car or a bullet fired from a gun. So any translational motion is associated with an important concept known as inertia, the property by virtue of which a body opposes any change in its state of rest or uniform motion along a straight line is nothing but inertia. This is according to Newton's first law of motion. And if the mass is more, then inertia is also more. If the mass is less, then the opposition is less, therefore inertia is less. And that rigid body can undergo rotational motion as well. A rigid body turns or rotates about an axis. For example, the blades of a fan, or when you open the door, that door is going to rotate about its hinges. These two can be taken as the simple examples, or else wheels rotating in a vehicle. All those are examples of rotational motion. A rigid body may execute both rotational and translational motions simultaneously. For example, a spinning cricket ball. When a bowler bowls a cricket ball, it undergoes translational as well as rotational motion simultaneously. Similarly, in a moving car, if you observe a wheel, that wheel undergoes simultaneous rotational as well as translational motion. So to understand the concept of moment of inertia, it is the property of a body to oppose the change in its state of rest or uniform rotation about an axis. As we have seen from the previous discussion, that is, with any translational motion, we have the property known as inertia. Similar to that, in case of rotational motion, we have this particular quantity known as the moment of inertia. So this is the property which opposes any change in its state of rest or uniform rotational motion about an axis. So now, this from the translational motion, what we have seen is the inertia depends on the mass. So whereas the moment of inertia in case of rotational motion depends on mass as well as another important aspect, that is the axis of rotation. For a same body, if the axis of rotation changes, then the moment of inertia also changes. So now, the moment of inertia, to quantify it, suppose if we consider a particle of mass m which is rotating about an axis. If r is the distance between the axis of rotation and the particle, then the moment of inertia I is equal to m into r square, mass into the square of the distance of the particle from the axis of rotation. So now, if we consider a rigid body, that rigid body can be assumed to be made up of large number of particles. Suppose if m1, m2, m3, etc. are the masses of those particles, and if r1, r2, r3, etc. are the distances of those particles from the axis of rotation, then the moment of inertia of the body as a whole can be written as I is equal to summation mi ri square, where I can take values 1 to n. N is nothing but the number of particles of which the rigid body is made up of. In general, I can be written as summation mr square, or I is equal to mk square. So where k represents the radius of gyration. So let us try to understand that radius of gyration. radius of gyration of a rigid body about an axis at which its center of mass coincides is the effective distance of its particles from the axis. It gives the same value of moment of inertia as it would be when calculated for actual distribution of mass. In general, radius of gyration is denoted by k, and it is equal to square root of I by m, where I is moment of inertia and m is mass of the object. For example, moment of inertia of a thin circular ring. Consider a thin circular ring of radius r. The moment of inertia of that ring about an axis passing through its center and perpendicular to its plane is equal to mr square. Now comparing this with the equation I is equal to mk square, we get radius of gyration as k is equal to r. That means when the axis is passing through the center and perpendicular to the plane, the radius of gyration is equal to radius. Whereas if we take the same ring, if the axis of rotation is along one of the diameters, then the moment of inertia is given by I is equal to mr square by 2, and comparing this with I is equal to mk square, we get the radius of gyration as k is equal to r divided by root 2. This is the radius of gyration. So what we can understand from this example is, so though the mass of the object is same, if the axis changes, then the moment of inertia also changes. Where whatever the radius of gyration we are talking about, that radius of gyration actually indicates the actual distribution of mass of the object or mass of the rigid body about the axis. If the axis changes, then the moment of inertia changes. Why it changes? Because the distribution of mass around the object or around the axis of rotation is going to change. So moving on to the theorems on moment of inertia. There are two important theorems. They are perpendicular axis theorem and parallel axis theorem. So these theorems helps us in giving the relationship between the moments of inertia of a body about different axes. Or else if the moment of inertia of the body about any one axis is known, then using these theorems you can estimate the moment of inertia of the object about any other axis. So the perpendicular axis theorem, it states that the moment of inertia of a plane lamina about an axis perpendicular to its plane is equal to sum of moments of inertia of the lamina about two mutually perpendicular axes in its plane and intersecting at the point where the perpendicular axis passes through it. This is the statement of perpendicular axis theorem. So to understand the statement, consider a plane lamina. So let O be the point where the axis is actually passing through. X, Y and Z are the three axes, OX, OY and OZ axis. Suppose if you calculate the moments of inertia about the two axes OX and OY, these two axes are there on the plane of the lamina. So those moment of inertia are Ix and Iy. So now if you calculate the moment of inertia about the third axis, that is OZ, which is perpendicular to the plane of the lamina, according to perpendicular axis theorem, Iz is equal to Ix plus Iy. What you need to remember in this case is, OX and OY are two axes which are there on the plane of the lamina, and OZ is the axis which is perpendicular to the plane of the lamina, but all the three axes are coinciding at a single point, that is O. They are meeting at the same point, that is O. This is one of the essential conditions for this perpendicular theorem to be applied anywhere. Moving on to the next thing, that is the parallel axis theorem. The moment of inertia of a body about any axis is equal to sum of the moment of inertia of the body about a parallel axis passing through the center of gravity and the product of mass of the body and square of the distance between the parallel axes. So to understand that statement, consider a rigid body. So in that rigid body we have two axes. One axis is passing through the point O, another axis is passing through the point G, where G is nothing but the center of gravity, and R is the distance of separation between the two parallel axes. If I is the moment of inertia about an axis passing through the point O, and Ig is the moment of inertia about an axis passing through the center of gravity, in that case I can be written as Ig plus mr square according to. Hope you have understood the concepts of moment of inertia, radius of gyration, the theorems on perpendicular axis and parallel axis. Thank you.